right, and we are now switching gears to wind. So atmospheric circulation and wind patterns. So air moves in response to variations in air pressure. It moves from high pressure to low pressure. Wind accounts for a minor amount of sediment erosion and transport. But regionally, it's very important. It's if you live where this is happening, it is what is going on, but it is minor on the global scale. Here's a diagram of Hadley cells. So this is low pressure and high pressure. So the sun, we were talking about, the tilt of the Earth, but the sun is hitting here pretty directly along the equator. And so that makes everything rise, creating low pressure at the surface. And then it goes up into the atmosphere where it's colder out there towards space. It cools off and then it comes back down here, and you have a high pressure system. And then you have low pressure, high pressure. It just kind of repeats. So what you'll find is you'll see deserts at these high pressure systems where it barely ever rains. As well as if you notice down here at the poles. So like Antarctica is technically a desert, just covered in like it's a frozen desert. Wind erosion consists of abrasion, forms of ventifex, deflation, and desert pavement. So, wind abrasion, wind picks up little sand pieces and then throws those at the whatever it is it's eroding, and it just like bit by bit tears at it. Uh, Rocks that have been oddly shaped from wind abrasion we call ventifex. And then where it's picking up the sand grains from, that's deflation. So you lose the sediment there. And then what's left behind, much like at the beach, what's left behind is your heavier material, like your gravels and things, and we call that desert pavement. And this could be kind of like calcified too if you had any precipitation like flowing in, and then it gets into like the hot desert valley floor and it evaporates those salts or carbonates. So it can be very hard sediment here. Definitely not like a soil that's going to grow anything. Um, Wind deposition. So that was erosion. This is deposition. Typically, you think sand dunes, although it's not the only deposition you can get. And sand dunes, pretty much that's just where the wind dumps piles of sand it has picked up. They move through time because the wind continues to blow. And so as the wind's blowing, not only is it picking up sand from over here and dumping it in this pile, usually this pile is caused from very commonly either almost trying to think if it's always from elevation change. Probably not, but I associate it with elevation change where the wind slows down as it starts going up like the mountains or like off the beach or something. And it drops it there. But then it keeps blowing. And so then it's also picking up sand grains and just kind of jumping them along, and then depositing them here on this slope, which is the slip face of the dune. And then in the rock record, that is actually what gets saved. Like this is the part you see of like an old sand dune field. And we call that cross bedded because it's very, oh, here we go. Like, so you can see here's a bed, here's a bed, here's a bed as this dune has migrated. And it looks like this. So this is dune cross bedding. And so this is it moved, it moved, it moved. And then right here, this little unconformity is like the wind changed direction. And so you get this cross-bedding, very pretty sandstones. Actually, if you ever get to go to Zion, Zion has some of the prettiest cross-bedding I've ever seen. And then here's just an aerial view of dune migration where you can just kind of like see how it's been like almost looks like it's been stretched or like it's flowing in the direction of the wind. Los is another wind deposit. It's globally kind of rare, but we do have it in Kentucky along this Mississippi River. Um, these are all sediments that have been picked up from like old glacial deposits and then drop down here. You get some up in the northwest as well. I think China has really big loess deposits. It's just not, you just don't plop anywhere on the planet and find loess. Anyway, it's really more silt than sand, but it's pretty much like the same thing, but it doesn't form that nice angle of repose. It's just like flat, thick deposits. And they're really good for farming, but they're kind of like weak soils. It's like a skeleton, like very porous, barely held together, so not suitable for building or even cutting into, like for the roads. It's just going to cave into the road. Nothing's really holding it together. Um, a little bit of earthquake and some water, just not structurally stable soils. Um, but farming, they're great for farming. Or I don't know about great, but decent for farming. Um, Deserts. So I'll just talk about here this little rain shadow first and go through the image. So on the leeward side of mountains, you almost, again, is this an always? No, very commonly you'll find deserts, and that's because as the wind and the carrying the moisture comes up into elevation, it cools, and the cold air doesn't uh, hold as much moisture. So it rains as it's climbing, it's dropping, it's just losing that like carrying capacity. And so then when it comes down the mountain, then it's already kind of been wrung out. Plus, it's getting the capability, it's becoming capable. It's warming up more and more and more, so it can actually hold more water, but it's already been dried out or wrung out. So not only is it not raining, it's actually increasing evaporation and wanting to pick up more moisture from the surface on the rain shadow side. Death Valley is in the rain shadow. So Death Valley is actually at that 30-degree mark, more or less, where you're having high pressure come down and not much rain because of that. Plus, it's in the rain shadow of the Sierra Nevada mountains. Orographic effect just means that topography is like creating that local desert, rain shadow. Okay, then desert. So technically a desert receives less than 25 centimeters of precipitation a year, and it has very limited vegetation. Arid regions are kind of in between deserts and normal, I guess. Um, what does it say by definition? Loses more water than it receives per year. Natural deserts are found at that 30-degree latitude mark where that Hadley cell is coming down, also at the poles. Um, and that's because of the dry descending and warm air and masses. So pretty much the same thing happens as I explained here, where it kind of rings out as it comes down, it's warming up and able to hold more water, so it kind of promotes evaporation instead of precipitation. And that's the same concept here that's happening like in the atmosphere, not related to topography, is it's warming up and coming down and super dry, and it's just wanting to pick up as much moisture as it can. Um, okay. Desertification. So, as things are becoming, if we're getting less water and we're hurting vegetation, then either we as human caused or even natural, but deserts can be created or newly formed in arid lands. So here we have the definition: arid is less than 250 millimeters or 10 inches a year. Semi-arid is 10 to 20 inches a year. Um, Causes of desertification: rapid development, um, disturbing vegetation, and using up all of our water in the area. And that is it for wind and deserts.